Thank you very much for joining this session. During this presentation, we will have a look at BadUSB attacks and also defensive methods, because a lot of people are talking about how can we attack using BadUSB, but not a lot of them are talking how can we protect against BadUSB and against technologies like rubber duckies and such malicious USB. So, have you ever played with a little BadUSB like this one? Hands up if you're done. So, okay. So we have some plenty experienced people here. Basically, what we will go through this presentation is how attackers are leveraging BadUSB attacks, how they can bypass some defensive mechanisms, and how we, as security professionals, can protect against those attacks. Firstly, some words about myself. I'm a technical person, so coming from a penetration testing, ethical hacking background, with some certifications on the list. Also founder of multiple companies. ZeroTac is a service provider for offensive penetration testing and operations. Then president for National Romanian Cybersecurity Training Center of Excellence, where we train the next generations of cybersecurity experts. And also trainer for other entities such as US Department of Defense, Polish military CERT, and so on. And we also organize BSIS Transylvania in Romania next year. So let's get to our scenario, which we see mostly in real life. We have our beloved Bob. Bob goes to the parking lot and he finds a little USB. He doesn't know that this USB is actually a malicious one, is a BadUSB. So he picks up the USB, and basically what Bob does is going up to his office and introduce the BadUSB into his computer. Next, basically Bob's computer is compromised, and attackers perform lateral movements, gained domain admin, because the initial access was through a physical medium, respectively through a BadUSB. But how it happened? Because this organization has basically Windows Defender enabled globally to all the computers, and not only Windows Defender, but the ADR from Microsoft, and also Bob is enforced as a low-privileged account. And the overall policy for removable media storage forbids inserting and executing USBs through the computers. So basically, this is the scenario. This is what happened in the background. This is the technical perspective. This is the sequence of attacks, respectively. We have firstly an AMSI bypass technique that we'll take a look over. Then we have basically execution policy bypass to evade the low privileged account permissions. Then a payload runner, because we want to be stealthy, we want to be fileless, so we inject everything in memory. And we'll see how can we defend then from all of those attacks. Firstly, let's take a look over the AMSI bypass that will embed into the BadUSB that was used to trigger the AV evasion. It's basically manipulation of the AMSI scan buffer function from AMSI.dll library. So it's actually memory patching of a function that is responsible for scanning all the PowerShell scripts that we run within the target computers. And this function right here, we will replace its value in memory with another value. AMSI stands for Anti-Malware Scanning Interface, and think about it as a middleman between what antivirus product you have installed on your computer and all the PowerShell scripts or other scripts that are being run on the computer. It sends the scripts to the antivirus engine for scanning for known signatures, for known malicious behaviors and things of the nature. So if we bypass this function, we might run any scripts that we want. And basically, let's move into the technical details. Because if we want to know how to protect against those attacks, we firstly must know how they are being made. This here, can you recognize this code? Like the programming language that is being written in? Yeah, okay, so it's C#. And basically we are using C# with PowerShell. Add type in PowerShell, which allows us to convert the C# code to PowerShell. Why are we using this combination? Basically, PowerShell is limited. It's limited on the Windows native API functions that we can call and can modify. So we'll define them through C# and then we'll play with them in memory. As you can see, get proc address, load library, and virtual protect. All Windows native functions that we'll use to manipulate our AMSI scan buffer function. Firstly, because the AMSI scan buffer is taken from the AMSI.dll, we must load that library in memory. So using load library that we just defined previously, we load the AMSI.dll into the memory. Then, using get proc address, we'll take the memory address of the AMSI scan buffer right here, AMSI scan buffer function, which we discussed previously. And basically using virtual protect, we will make it writable in memory. So we can patch it. We can do a replacement of the actual function. And the replacement value is right here. It's an assembly instruction that will return this value anytime the function is being called. And why this value? Basically, we'll see during the next slide. Also, here we do the actual replacement using a technique called Marshall copy, which basically copies our previously built value into the memory address of the function. And why this value? Basically, this one is an result error code for the AMSI scan buffer function. And if we take a look at the official documentation, this is all Microsoft. So it says, if this function succeeds, it returns S_OK. Otherwise, it returns an result error code. So basically what Microsoft didn't mention on this official documentation is that if the function itself, the AMSI scan buffer function, returns an result error code, it will run regardless of the scripts that we provide to the function as arguments. So if our function, if we try and we accomplish this, we can run any PowerShell script that we want through the AMSI scan buffer function. And those result error codes, we can take them from Microsoft also. It's a pretty big list from where we can take them, and you can take any of them. Next, this is basically our payload that will embed into our BadUSB, but it is not finished yet. Do you suggest something that we can do here to make it more undetectable? Yes, please?
Patch.
Sorry?
Patch ETW.
Page what?
ETW.
ETW. Where you see it? Yes. No, basically, it's more simple. It's more simple than that. It's more simple than that. Don't think about the behavior. Think about the static form of the script. Yes, that could be also, but you go into a more complex direction. It's much easier. It's obfuscation, basically. You can apply obfuscation, just like take something like invoke obfuscation from GitHub. It's basically an open source obfuscator for PowerShell scripts, and you can transform the script like this. So it's pretty straightforward. It's simple than modifying the actual behavior. And basically, here we have the script obfuscated, as you can see, but the C# code is not obfuscated. When you try to convert C# to PowerShell, do not apply obfuscation over the C# code. Why? Because it will break the code itself. It will not convert properly, and the payload will not work. So we have the script here, and then let's see how our attacker bypassed the low privilege account. Basically, have you run into this error before? I mean, it's pretty common. It's an error that is the result of the enforcement of execution policy. And in Windows, we can have this execution policy to disallow low privileged accounts to run unsigned and untrusted PowerShell scripts. So what we can do actually, we can manage and set our own execution policy to unrestricted. We had a discussion with Microsoft about this issue, and they said it's basically part of a feature, and it's not a security problem, which is great. I assume so. We can use this feature in our own purposes, and basically using this payload right here, we can set, as you can see, unrestricted with the scope of current user, which means our low privileged user. And then let's see how we can put everything together on a fileless to become fileless. So don't leave any traces and don't leave any artifacts within the victims. And basically, we'll not go into too many details here because we are running out of time. So this is basically a function that is used to search for assembly references within the memory. And then we have the getDelegateType function, which is used to set the argument types for the Windows API native functions that we just defined previously. Why it is necessary to have such a function? Because integers, pointers, and all those argument types that are defined through the Windows API native functions are not known by PowerShell. So PowerShell doesn't have that context to be able to set them and to be able to provide them to the function as arguments. And then we basically need a memory space within our victim memory to allocate that space for our shellcode, because our objective is to get a reverse shellcode, or the attacker's objectives are to gain basically initial access into the organization. And here we use virtual alloc to allocate the actual memory space for our shellcode. And as you can see here, we can create a very simple Meterpreter reverse shell. It's Windows x64 Meterpreter reverse TCP. Must be or might be catched by any antivirus products or any defensive solutions out there. But does it? We will see. Basically, what space you allocate here must match the space, the payload size of your payload. This is a very, very important step. And then basically we can do again a partial copy to copy the values of the shellcode directly into the previously allocated memory space. And using the create thread function, also again a Windows native API function, with, as you can see here right in the corner, with the get delegate type function, which sets the argument types for the create thread function. We will execute our previously partial copied memory space, which contains our whole shellcode. And this is basically how you can do it fileless and how you can do it directly into the memory. Now, let's get into a little tutorial about BadUSBs and how you can program them. Basically, the BadUSB, it's not a removable media storage. So if you have a policy regarding removable media storage, it will not work because it is not identified as a device of that type. It's actually a simulation of a keyboard and a mouse. Within its case, it's basically an Arduino microchip here, which you can program to do anything you want, especially to simulate keystrokes from a keyboard using functions from the keyboard.hash library. And how can we program it? Basically, we have two options. Firstly, would be to make it using C++, which is, you need to have more knowledge in this area. I'm not a programmer of C++, so I tried to find a way to do it simpler. So if you heard before of rubber duckies, you know that they provide you a custom syntax. Very, very basic custom syntax, user-friendly custom syntax. And you can use that syntax into a ducky script to Arduino converter online, which is basically Duckwino. Here is the GitHub link to it. And you can insert the ducky script in order to convert it to Arduino script, which then you can embed directly on the BadUSB. And if you wonder how simple it is, the ducky script syntax, it is like this. So we have the string command, which basically it will type the keystrokes after we insert it into our ducky script. So it means that if we have right here in the corner string PowerShell.exe, our BadUSB, respectively our Arduino, will type PowerShell.exe into the victim computer. Then we have delays. If our victim is slow, basically old computer, we might use delays in order to make the payload a little bit slower, because from experience, Windows 7, Windows XP doesn't keep up the pace with the BadUSB. It's too fast. And rem comes from the comment. Repeat X is basically a loop that repeats the last command X times. And very important, the special keys like Enter, Tab, Control, Shift, and all of those must be typed into the ducky script as we have them on the keyboard in order to be pressed, to simulate a keystroke press of those keys. And then we have the guy command, which is basically the Windows key. And we can also simulate the mouse pointers. And this is very important. When do you think we or an attacker can use the mouse pointers? What would be the scenario when we might use the mouse pointer to bypass something? Any idea?
USC.
Sorry? Yes, USC. Basically, or when we have the lock screen into our Windows, when we target a lock screened Windows that doesn't require a password. So we need to simulate that sign in mouse press of the button in order to sign into the Windows or to bypass the USC when we want to run with administrator privileges. And we can do that using mouse move, which will basically move the pointer of our mouse to the coordinates that we insert into the script. And then we have L mouse, M mouse, and R mouse, which comes from left mouse, right mouse, and middle mouse. Those are the buttons from the mouse. Okay, so now let's see a quick demo of how it works. Here, for example, we simulate an attacker and a victim, right? So, firstly, as an attacker, we have our infrastructure. Of course, normal attackers are not hosting their infrastructure on AWS, but we try to simulate this attack. So we have here a C2 hosted in AWS that we must connect firstly to it. Just 1 second right now. Okay. And the key. It's basically a Kali machine. So a Kali Linux machine. And we'll use the Metasploit framework for listening for the actual reverse shell. And we are starting it right now. Starting the Metasploit framework. And within Metasploit framework, we'll use exploit/multi/handler, which is the default listener within Metasploit. And the payload, we need to set the payload, the same payload as we set during the generation of our shellcode. So set payload, Windows, x64, Meterpreter, reverse _TCP. Set listening host will be 000, so we are trying to catch anything. And set listening port, the same port that we set during our generation of the payload. So set listening port to 443. And let's run it. Now we are listening for a connection. Now let's switch the roles and let's suppose we are Bob. Bob, what he does, it inserts the BadUSB into the computer. And the BadUSB starts typing some commands. This is the AMSI bypass right here. You see the value right there. Then we have basically the getDelegate type function with the virtual alloc to make the memory writable, with the shellcode being inserted into a variable, and then Marshall copy the shellcode into the memory, and then we have right here the create thread to execute the memory location. And let's check our listener in the background. We have a Meterpreter shell right here with, just give me 1 second. Okay, to show you with real-time protection on. So Windows Defender has real-time protection on, and we just got the reverse shell of Meterpreter. And we can jump directly into a shell. Let me make it bigger for you. We can jump, okay, I will make it smaller. Okay, so we can join into a shell and we can do other things. For example, we are in Meterpreter, so we can load Meterpreter modules, load Mimikatz, for example, and yeah, some Ruby errors, but it's a success. So we just run Meterpreter. I'll not dump the hashes because some passwords may be personal here, and we don't have the privileges because we are running under a low privilege account. So now the question is, how can we protect against those attacks? And basically, we have a lot of options. Some of them are just mitigations. Some of them are actually legit options to protect against those types of attacks. And let's see basically what are, okay, 1 second to switch to the presentation. What are our options to prevent those attacks? And I leave the shellcode there to show you that it will not be triggered after 2-3 minutes. So it's also persistent. So firstly, like some security best practices or hygiene checks, we must disallow PowerShell and optionally CMD for all the end users. How can we do it? Through execution policy, it's not that effective, as you've seen. If you know, basically, Active Directory provides you the option to disable PowerShell, to disable the CMD entirely for the whole organization, for some specific computers, or for some specific users. So use that because that is harder to bypass. Then we can have port blockers, which I'll show during the next slide. What is a port blocker? Which will restrict access to the actually physical port of the device. So basically, Bob now cannot insert anymore any USB device. But be very aware that not USB ports are vulnerable. We have also bad USB cables that also have Arduino in them. So we must search for USB. We must search for port blockers that blocks also the Type-C, for example, ports. And then switch a little bit the perspective from relying on an antivirus, from relying on default defenses that some operating systems provide us, to move towards a more advanced defense like endpoint protection, ADR, XDR, and things of that nature. And as everyone recommends, security awareness. Don't be Bob. So next, this is how a port blocker looks like. So this is actually like you insert it within your physical port, switch it, take the key, and that's it. The device cannot be abused anymore through physical USBs, and the administrator can have the keys to those USB port blockers. And I didn't see too many, but there are some of them that blocks also Type-C ports. I must search a little more for that one. And basically, besides that, there is a very nice tool that we can use, and we'll take a look at it. It's basically the duck hunt. Have you heard of this one before? No? Okay, perfect. So, what is this duck hunt? Basically, it's a script. It's a tool, open source. So it's open source that runs on the computers, and it will identify, basically it will trigger when your typing speed is not associated with a normal human typing speed. Because in that case, you can basically identify the quick BadUSB attacks or rubber duckies attacks. But the problem is that attackers can bypass in some cases those scripts because they can put delays into typing the commands, into typing the payloads. But here is also a catch. For example, we as users, if we insert an USB and if we correlate this tool with a good security awareness strategy, we might get to the point where the user, even if the rubber ducky or BadUSB is typing slower, the user will recognize that he or she is abused when they see the terminal or when they see the PowerShell command prompt up and something is typed on that PowerShell prompt or that CMD prompt. So this standalone, it's not working as a prevention. It's just a very, very interesting mitigation of those attacks because, as I said, they can be bypassed using sleep delays. And let's take a look over it. It's Duck Hunt. It's on GitHub. And if we copy it, okay. It's loading. So basically, it can be in Python format. I know it can be also run as an executable, and it has multiple modes for protections. But what I want to show you is how it's being set up within the computer. Basically, it can be set up as a startup program, so it will run in the background. And if you want to go it more deeper, you can have it as a service, and an actual service that is not stoppable, not removable, because if we run it just as a startup program, an attacker may bypass it, right? They may just kill the process, and that's it. But if you run it as a persistent network service, it might do the job properly. And I think we are running a little bit to the end of the presentation, and I want some minutes for Q&A. Yeah. Okay, so that was it so far. I know that you might have some questions regarding the tools. We have 7 minutes of Q&A and discussions about this attack, about how can we prevent. So just feel free to ask anything.
Thank you.
Good go.
Okay.
So, are there any questions or curiosities about this attack, or maybe about the prevention?
Okay, here you go.
So we saw that there's basically the type speed, right, and the block list. Once I was on a working station in our office, and I plugged in a second keyboard, a real keyboard, and I got a pop-up, which I never could find again Googling or using other workstations. So do you have an idea what that could have been? Was it an admin writing a super fancy PowerShell script that catches this driver thing? And could that be something that we could use? And so, because there's already a keyboard that it asks the user if he wants to have a second one.
Yes. So basically, you can use the behavior. Firstly, the behavior of the user, but then the identification. You can identify the devices that you insert, but that one can be also spoofed. That's the problem. So it's just a mitigation, it's not a prevention. What was listed here is basically the defensive mechanisms that have been researched for this method, and we present them to the clients. Other methods might have really easy bypasses, like identification based on MAC address, for example. That one you can spoof. Actually, you can simulate Logitech keyboard, for example, from the device itself.
Eventually, you may want to look at GData USB keyboard card. That's a free tool. And whenever you plug in a keyboard, you have to key in 7 numbers with the mouse. That's something that helps in certain cases, not in all of them, but at least it's a little bit of a surprise for the attacker.
Mm-hmm. Yes. Okay, so yes, please.
Hi. So one question regarding the input from the device. Does it look which keyboard layout is used? So there might be some interferences. So you write a script for a German keyboard, but then you have a English keyboard, so it mix up some letters.
Yes, that's a problem also. You need to research your targets very well before sending those USBs. Some countries have other keyboard layouts, and basically the keystrokes are pressed as they are typed on the script. And for example, if you have a replacement of the Z character, as with other character on the keyboard layout, the one that is being typed by the BadUSB, it's the actual key that was replaced by the Z character. So that's the problem. Or if you have Arabic keystrokes, or if you have other type of keystrokes, you must type them as they are on the keyboard itself. So yeah, that would be a natural, let's call it a natural mitigation or natural prevention of this attack. So yeah, okay. Any other question? If not, we can discuss after. So thank you very much. Thank you.
Thank you, Cristian.